Okay, we'll give it a minute. People are filing in, I can see on the participant list. So we'll give it about a minute and then I'll go ahead and launch our webinar formally. All right, everyone, I think we can begin. I want to welcome you to this Water UCI colloquium on remediation, regulation, reform, what we're doing about PFAS in our water. As many of you know, this is an extremely important issue that is facing our nation. And we have the privilege of being able to host 4 distinguished experts on this subject, and they are again going to concentrate on remediation, regulation, and reform. I want to introduce to you Michael Wong, who is a treatment engineer and technologist for Jacobs Engineering Group. Eugene Lung, who is drinking water treatment technical specialist for California State Water Board's Division of Drinking Water. Al Javier, the Director of Environmental and Regulatory Compliance for the Eastern Municipal Water District here in Southern California. And Jennifer Field is a professor of environmental and molecular toxicology at Oregon State University in Corvallis. Welcome, everyone. The format for this colloquium will be very simple. We have a series of prearranged questions, and I'm going to ask our panelists to address these questions in turn and to go in any direction they feel is appropriate in terms of their area of expertise and concern. After that, we will then open up the webinar to audience questions. Those of you who have questions, please use the Q&A function on the Zoom webinar link, and then we will go through the questions and toss them to the panelists. So our first question, which I'm going to ask the panelists to address, is the following. Typically, we address water pollution and contaminants of concern as an end of pipe problem. We identify a contaminant, monitor its concentration, and introduce measures to treat or remove it. What do you think are some of the most promising technical solutions for remediation, and what are some alternatives we may need to consider for more effectively addressing PFAS? And if I may, if we could begin with Professor Field.
Good afternoon, and thanks for letting me join. It's a real privilege. I'm more of a chemist, so I'll say that I can fully appreciate the practitioner wanting answers to this complex problem. But if I may step back a moment and say, well, what is that problem? And so you mentioned that it is a national problem. It's occurring in quite a few different locations. I think one thing to appreciate if you're not yet in this field or haven't done much with it is we often see PFAS, which is this acronym standing for per and polyfluoroalkyl substances. That's a big term, but like, what is it? And so it really, at the moment, it's many classes that kind of have an umbrella feature to them, and that's this highly fluorinated part of their tail. But as new alternatives show up, alternatives in the sense of substitutions that have come on the market in the last 10, 20, actually substitutes been around for a while. It isn't always just a fully fluorinated tail. You can actually punctuate the oxygen. And so now what we've got quite a few classes, and we have many members within each class. So what we can end up with, particularly in some applications like aqueous film forming foams or AFFF, is many compounds, right? That belong together, that were used together, that function in this product together, but it really presents a challenge today. So when you think about end of pipe or what PFAS are out there, it may go well beyond what we might think of as just PFAS or PFOA. So I think appreciating the breadth of the substances and the challenges they present to our engineers. For example, if you have really short PFAS, they're much more difficult to capture efficiently on GAC. Somebody else might mention that today. And other the longer chain materials might not move very much, might not actually see them in water, right? That might be more of a soil problem. And so because we have such big classes with many, many members, it's really very challenging for one of those reasons. In terms of treatment, with that in mind, I see kind of two buckets out there. There's this question of technology. How do I get it out of water and put it in a media like granulated activated carbon? And then there's destruction. And we've got people and researchers working not only in the US, but around the world on those and other approaches. And so I think that's it's a great white world out there, but I think let's hear from practitioners and what they see is in their toolbox.
Very good. With that, Eugene, would you like to comment first?
Sure, thank you very much. So I work for the Division of Drinking Water, and we regulate all the public water systems in California. So what we have done right now is really looking at occurrence, and also our partner agency within the water boards, the Division of Water Quality, they have actually issued investigation orders for like what are the typical sources for PFAS that we have seen. I think the AFFF that Jennifer's mentioned is for firefighting foam, probably the most common that people think about it. And that turned out to be true in actually when they go into the order and monitoring for sources around airports where they have the firefighting foam use. I think they have been able to detect PFAS in a lot of the groundwater wells around those sources. But on top of that, I think they've looked into landfills and chrome platers. So these are industrial sites, and also for just general landfills, municipal landfills. And they're able to find PFAS in the leachate. So there are actually, it's beyond airports. There are definitely multiple sources of the contaminant leaching into the groundwater. So us as the Division of Drinking Water, we're issuing orders right now for wells that are located near these potential contaminating activities to see what's being found in the for my focus, looking at how to make the drinking water safe for human consumption, exactly what Jennifer mentioned. Like for some of the water that may have the longer chain PFAS, we'll be using granulated activated carbon for treatment. But if we find to be the shorter chains, we may need to use other treatment techniques, such as using ion exchange or maybe using reverse osmosis. And I know Michael will touch into that as well. Those are kind of like the more typical tools that we have in our tool belt. I think there are some also new adsorbents being developed that could be used in a similar manner. And so those are the kind of the key things we do for the drinking water treatment at the end of pipe. I think it will be probably similar to a lot of these, is to really look at if these potential contaminating sources, are they still continually being as the source of the contaminant to these drinking water sources, or if there's some way for us to stop it. So I think that's goes back to a lot of the other groundwater contaminants. I guess, would there be some sort of a pump and treat effort or something like that to stop it from spreading into the drinking water, so that we'll see the source being cut off, and then how to contain and clean up the sources in the long run of the contaminant. So I think that's my contribution to this conversation.
Thank you very much, Eugene. It's a good segue, Michael, to you.
Thanks, Eugene. Yeah, so if we look at the adsorbent media that's been used for many years, other type of contaminants, granular activated carbon, which has been used to remove just mix and precursors to byproducts. It is a very effective way to remove PFAS, and it's pretty well understood. Anion exchange, I think, is the other adsorbent that's commercially available and that a lot of the utilities right now are looking at putting in to treat the PFAS that's in their groundwater supplies. I think from a practical standpoint, if we step back and look at where the PFAS is being detected from a source standpoint for drinking water, a lot of these are in the groundwater where retail agencies and utilities, they already have existing well sites. And those existing well sites, sometimes it's just a single well with like 1,000 to 2,000 or 3,000 GPM. And it might be located, in a neighborhood, and there may not be a lot of space around to to put in a huge treatment plant, or if you have a bunch of wells in an area, you could think about having a centralized treatment plant to all that, but then you have to think about the costs of conveyance to bring that all to a site, assuming you have the space to do that. And so, GAC and ion exchange, like those are media that can be loaded into pressure vessels that can be sited in spots that have limited footprint. And I think that's why a lot of the folks in the industry that are trying to solve these problems, that's what they're looking at putting in, because for decentralized systems, that's the best fit. Reverse osmosis, high pressure membranes, as many of you know, it's often used to take out dissolved constituents, and it is a very good process for removing PFAS. That's pretty well documented in the literature. The challenge, I think, with reverse osmosis is the space that's required may not be, you may not be able to accommodate for that at a single small well. You might be able to accommodate it if you have a larger site for centralized treatment. And the other challenge that reverse osmosis presents is you do have a waste stream that's continuously generated that has to be discharged. So if you don't already have a discharge point to do that, you have to think about the cost and how to handle that waste. I think Al has some good examples from the work that they're doing at Eastern Municipal Water District that I think can kind of build on the things that I just mentioned.
Excellent. Thank you, Michael. Al, we'd like to hear from you.
Yeah, thank you. Thanks, everyone. Yes, we do have a GAC unit, the granularly active carbon, that just started operation anyway. I'll talk about that a little bit later because there's another question that actually that I'll concentrate on. The other thing that I will probably focus on is everyone's been focusing on the potable. I'm going to talk about the wastewater side. And the other things, instead of looking at it at the end of the pipe, I'm looking at it at the initial source, where it comes from, where it's discharged into the sewer lines, and doing what's called source management, or looking at source control itself. The other thing is looking at the manufacturing of PFAS and the different varieties that there are, but also making sure that the products that can bleach these are no longer available or are seen very closely. I know legislatively, lawmakers are now looking at that and making sure that those things are not included, as well as the regulating field for those for products, making sure that that's been included in there. The other thing is actually at the source level, when we discharge a sewer line, is making sure that those with new regulations based on the requirements of our discharge, because we can either discharge our wastewater to land or discharge to streams, body streams. So there's two different types. Based on that requirements, we can actually enforce our dischargers that are going into our sewer lines and kind of limit their discharge based on the requirements that's there. So more or less, instead of doing the end of pipe, I'm looking more at the source and upstream of that.
Excellent. Thank you, all four of you. I do want to remind you before we go to our next question that this entire webinar is being recorded and will be posted on our YouTube page beginning tomorrow. So for those of you whose colleagues were not able to attend, or students whom you'd like to review this, it will be available. Our next question is as follows. Given the costs of treatment that will likely fall upon water agencies and their ratepayers to repair, to remediate the problems caused by PFAS, are there feasible remedies that could be placed on industry, manufacturers, even users of PFAS containing products to pay for this remediation effort? Let me start, if I may, with Professor Field. I think you're still muted, Jennifer.
Sorry.
No problem.
You raise a kind of a quandary. I'm not convinced that every user knows they're a user, simply because they can pop up in materials or processes that aren't necessarily, actively being, purchased. They can show up in lots of different things. So I think it's a challenge for industries to actually know their inventory and to be aware of that. And so when you go and as Al is talking about, and you're trying to trace back, I'm going to guess there's an educational component here to actually track it down. And there might be some people or businesses who don't really realize their user. I can think of, there's a product we have seen manufactured in an area of the LA area. It's a face product. It's loaded with PFAS. It even says it on the bottle. So there might be a case where they deliberately reached out, but there might also be cases where they're unaware. So I think raising awareness, doing source tracing is a big deal and may actually go a long way toward understanding. And then, of course, not a new idea is really the one that the Green Science Policy Institute is pushing, and that is, well, when is it necessary? So if you are a user, what is that functionality? Is there no substitute? And getting people to examine what are the critical applications and where can they be removed and where is there a substitute? And AFFF is an example where there are substitutes. They have been adopted in other countries by other agencies that are trying to eliminate the PFAS. So you'll see that in Australia and Norway. Here, it's complicated in part because I've been asked, like, well, why doesn't our military just go to the fluorine free? Well, our military is a very, very large organization. It's probably bigger than, 20 Norways taped together. So when you talk about changing our system or pieces of our system, it's a very large undertaking. So I think the question is fully appreciated. Just how to do that. For example, if you go to a PFAS-free AFFF, my understanding is that the properties of the fluid changes, how you can pump it, how viscous, how do you deliver it? Does it flow? Like, for example, if you're in a large hangar and you need it to flow underneath an aircraft, you need that viscosity to be pretty low. So if you do make changes, like in the Brisbane airport in Australia, they've entirely changed how they protect the firefighters. So they are practicing closer to fires. They have a different PPE. And this is to accommodate those changes. So I think what I'm learning is that how much infrastructure in some cases has to change along with it. So it's not like, oh, we're just refusing to have a substitute. There's this infrastructure that goes with it. And the bigger the infrastructure, the more difficult it is to change. So that's maybe why you're not seeing as rapid a movement in some sectors as maybe others. If you're a smaller user, maybe you're more nimble. Maybe you can find substitutes and you might see changes in these smaller, more nimble type of industries.
Excellent. Thank you very much. Eugene, to you.
I think another area it's the difficulty to pin down is because the products, the PFAS family of products is used in so many consumer products because of the stain resistant characteristic of the chemical. So in our sister agencies, like the Department of Toxic Substance Control, for example, they're working on standards for carpets and rugs for the stain to identify what chemicals being used on the carpets, what's potentially released from these products. And what happens, what's the fate of these products when it's the spent carpet being disposed of it in the landfill, and all of this chemical can potentially leach from it. So I think there's a lot of difficulties right now for us because there are so many day-to-day products that we use that contains PFAS, either previously made or that's coming on the market with newer formulation. So it's really hard to pin down how to stop it because we like those products as consumers. So I think that becomes a real challenge for all of us, that we like the jackets that repels waters, that repel stains, and carpets that's easy to clean. But now how do we figure out a way, because all of these will be contributing with a lot of chemicals, I'm sure Jennifer, that even with the newer formulation, all of them are still really stable. And we'll have an ongoing challenge to kind of like identify the continuous source to help fund cleaning up these so many different types of this family of chemicals that we'll find in groundwater. So I think that's where our challenge is. There's not a simple answer, unfortunately.
Well, indeed, very complex problem, and thank you for reaffirming that, Eugene. Michael, let's go to you.
Yeah, I'll build on what Eugene was saying, I think another challenge is, when we look at, say, for example, someone like 3M and the production of PFOS, there's some literature out there that shows that many years ago, like in the early 2000s, because of the health concerns they became aware of, like they started ramping down production of that. And so you think that maybe it wouldn't be in our products if one of the biggest producers has kind of, stepped back from that production. But then if you look at the graphs of production of PFOS in countries that import consumer products to the US, like China, you see that those graphs, ramp up right around that time. And so even though it might not be produced, within, the US, those products that we still buy on Amazon or at stores, like, we cannot control, how those products are making it into our market. And we're the consumers, like Eugene said, like we like the Gore-Tex, we like the pizza boxes that, don't get our counters dirty, or you like to mountain bike and you want, your feet to be dry when you're doing that. And so I think it really becomes challenging when you're thinking about, where it's coming from and how to kind of get it out of the cycle. So I think that really does make it a challenging question in terms of, what you do about the products that are there. And I think, in the immediate term, retail agencies, like they have to address the concerns, right? And so that's why we see retail agencies moving right now to try to put in treatment, and how they recover that cost is a really important question for them.
Thank you very much, Michael. Al? I think you're still muted.
Thank you. I'm going to take a different approach to this. Obviously, the way the government would work is on issues that we have. It typically will be a super fund to provide monies for cleanups and such. The other ones is really right now is kind of having some attractions right now is coalition or cooperative groups that are going after the PFAS manufacturers. So typically this is the straightforward lawsuits or class action lawsuits. Trying to recover costs, because some of the back east in Michigan and Pennsylvania, where they were manufactured and discharged into streams, they're trying to meet the requirements for treatment. And so they're looking for the recovery of that cost for the rate players to treat this. And so this is one avenue that they look at. So just straightforward is the lawsuit itself, trying to get that the recovery to the rate payers or the ones that have discharged and are causing the issue too. So yeah, straightforward.
Excellent point, and a great segue to our next question, our third question. We know that the sources of many PFOS are military bases, other government-owned type of installations here and overseas. Given that remediation of contaminated government-owned hazardous sites in the past were often cleaned up through special partnership agreements between, let's say, EPA, states, and the Defense Department or the Department of Energy, other agencies. Is this a likely path that might be taken for the PFAS issue as well? And again, Professor Field, if we could start with you and your observations on this.
I have to admit, I don't have particular expertise in that question, but I could maybe touch on some aspects. So you mentioned that the AFFF, and it is really important. If you take a global look at production of highly fluorinated substances, it's a very small share of that market. Historically, it's only been 3%, but it's a special 3% because this material was designed to be used in the outdoors Historically, it's used repeatedly in single locations for training or practice or testing equipment. And so it was a live, uncontrolled release historically, and in emergencies, right? And so you've got, even though it's a small amount, it's a historically, because of this training that occurred on military bases, but not limited to military bases. That's where you get this really high buildup of concentration, simply because it's a very focused outdoor open release. And so we're really quite aware of what some of those impacts are. But Al was mentioning some other important sources earlier on. And so when you get to thinking about, well, who's going to be responsible, often we can see co-located businesses or entities. For example, even in our own Portland airport, you're going to have fuel storage, right? The airplanes need fuel, you have fuel storage. The oil and gas industry is its own user and stockpiler and supplier of AFFF, and they're often not too far away from their users, right? So airports is a good example. Because of different property values, you might co-locate a landfill, or a wastewater treatment plant will be very close by. And so what you got is what I call fence line partners. So different entities using different kinds of products, some of which they share, like AFFF. And then they get kind of mixed or blended or very close together. And this is one of the great challenges for the practitioners you have on today. People trying to figure out, like, whose is that? And I think one of the things that came up earlier is landfills. So in our experience, so I've been at this for about 25 years. And started with AFFF contaminated groundwater, but then moved into wastewater treatment plant systems, municipal systems, doing some of the earliest mass flows. We actually did it in our own hometown. And then we also moved on to landfills. And landfills, so the prize winners are, for the highest concentrations I've ever seen, are AFFF contaminated groundwater, where you're sitting right in those source zones. You can hit a part per million. We've seen, highest we've ever seen is 14 parts per million. It was actually sulfonate, maybe not one that everybody talks about, but it can get quite high. PFOA, we've seen 6 milligrams per liter. PFAS, I've seen 1 milligram per liter. So those are the real winners. Second prize goes to landfill leachates. They're very, very interesting mixture. They are not the same. They're heavily skewed toward the short chain because that's what leaches. So it kind of makes sense, right? The shorter chains tend to dominate. And there's some really interesting PFAS in there that might actually serve as markers. What I'm not sure is whether or not many entities catch it. I think of it, it's called the 5-3 FTCA. It's an intermediate that is formed in the transformation of some of the others. And landfills seem to have a nice hit of this. So we're very interested in helping people fingerprint sources. And so we're taking a very broad spectrum look, and we are seeing that landfills have a characteristic, some markers. Then of course, the third place winner is municipal wastewater. Of course, that depends on where you are, but I'm just talking about garden variety wastewater. And that is these are the great integrators, right? Wastewater is an integrator around the community, and we've got folks going upstream, and that's going to help. But we also want people to recognize that landfills and wastewater treatment plants are often clients of each other. Biosolids can go to your landfill. Landfill can export its leachate. And what we get is, as folks look more and more, is the interconnectedness. I think someone got at this a little bit earlier. For things that don't have breakdown pathways in the environment, they're just going to move and transfer. We can move them from wastewater onto biosolids, biosolids onto land into a crop. And so goes the cycle. So one of the really hard things here is, until you stop releasing them, it's very hard to stop the cycle because of this transfer phenomenon. So I think forensics is a hot area, and we're really trying to come up with tool sets, again, for practitioners like the folks here who are trying to decide who are your emitters and how to really get them in as part of that conversation to shut down the emissions if possible.
Excellent. Thank you very much. Eugene.
I think from Division of Drinking Water and from the water boards, I think the key part looking for responsible party, like there's so many upstream, right? As Jennifer explained, that like you said, the wastewater plant, they took their biosolids to the landfill that's causing the leachate to come on, all of that. I think will be a lot of investigative work by a regional water quality control boards, because they are the ones that are going to go really look into at least try to get the immediate cause of contamination for a particular municipal source, and that's where the funding comes in from my division is to how to make the water immediately safe for human consumption. But I think ultimately how to clean the contaminants that's going through this cycle, through the environment, through all the different modes, and how to ultimately remove it from the cycle. I think that's a bigger question. And for the regional board, I think that's their goal, to be able to do it. And I think I'm not sure where for PFAS where it's going to go, but I think as the question asks, I think it's going to be for military and all of that. I think it'll be very similar for the Superfund sites type. I suspect it'll be something because or you'll be the regional board working with the potential polluters and all of them, and with the impact of the utilities, and ultimately develop a program that it could be everybody will work together ultimately break the cycle and remove PFAS from the environment. So I think that's where we're going with it, but we are still in the investigative stage. So check back. I think we'll have a better picture of where we'll be going in a year or two.
Yeah, great point. And we definitely will be checking back on this issue and on several others that you all have mentioned this afternoon. Thank you. Michael.
I wanted to just echo one of the comments that Jennifer made about AFFF being a small percentage of the source of PFAS. So I think when we think about military sites that may have PFAS in surrounding groundwaters adjacent to their site, you got to remember that doesn't cover everything, right? There's areas where the influence may be from something else, consumer products over the years, from the wastewater, and so on and so forth. But if we go to the question and talk about military sites specifically, I think it's good to think about what the federal government has historically done with other contaminants like VOCs, right? There's existing programs in place that have been set up to address those contaminants that may be, nearby, their facilities. And so, a lot of these sites already have treatment in place to address other contaminants that they've been treating for years. And in some cases, depending on what type of treatment they have, it may be suitable to address PFAS if that's also a concern at the site. So if you have a site that has VOCs and they already have granular activated carbon that's been there, that treatment is going to work as well for PFAS, and it's already been funded. Other sites, they may have a different type of treatment in place, like air stripping, which, may address the contaminants that, they were put in for originally, like VOCs, but that may not be adequate to treat or it's not going to be adequate to treat for the PFAS. And so I think at those sites, depending on what the water is used for, like they have to think about whether the treatment they have needs to be replaced with something that can address the PFAS, or upgraded to include, an additional process. But I think it's good to keep in mind that there are programs in place to fund treatment at those sites already.
Thank you very much, Michael. Excellent. Al?
I'm going to have a story, and because we do have direct experience working with the DoD on this. So I'm going to share my screen and go through a couple slides.
Excellent. Excellent.
Oops.
Let's make sure you can.
I have been disabled as a host, so I cannot share my screen.
Shannon, can we enable?
Let me
Let's see
see.
if we can't. Let's see if we can't fix that.
Okay.
We definitely want to give you the opportunity to share.
So as I was mentioning before, we do have direct experience working with the Department of Defense at March Air Force Base.
I think you're good now.
Okay. Go through it right now.
Mm-hmm.
Whoops, wrong one. Let me stop sharing and share the right one. Oops. Now I'm getting confused here. Let's just go to that screen. We'll keep it this way. So everyone can see the screen right now. So what we had is back in May 2016, EPA had established the Life Health Advisory. They lowered it down to 70 parts per trillion for PFOA and PFOS combined. At the time, the March Air Force Base had conducted some well studies. And what we found is we had 2 wells of EMWD. If you look to the south, we have EMWD well 59 and well 56 to the south, and there were 2 private wells to the east. The source of the PFAS was actually from the firefighting training site, which is Site 7 on March Air Force Base. When we detected this and it was exceeding the health advisory, we immediately shut down well 59, as well as the 2 private wells were provided bottled water for drinking on there. Additionally, later on, back in 2019, we also had well 56 that actually shut down. It was still below the EPA health advisory, but when the state changed its notification level, it exceeded that, so we shut that down. So one of the things that March Air Force did is they did an expanded site inspection report. And what they did is they delineated the PFAS plume that came out of March Air Force Base. So what you're looking at here in the map to the right is a plume diagram of 2 different aquifers combined. They did 2 levels of the aquifers and looking at it. The blue or the light blue is actually at 70 parts. Mind you, there's a big difference when we're working with the Department of Defense as well as the state. The state has, as Eugene has indicated, the state are usually ahead of the EPA. And so the DoD only recognizes EPA regulations, even though we might exceed MCLs to the state. The Department of Defense doesn't recognize that and will not any remediation action for that. So that's why this map only goes down to the 70 part, which is the EPA health advisory. As you can see, the plume goes down to about 2.4 miles to the south and 1.5 miles to the east. It should be noted that the groundwater flow moves into the southeast and then goes south. So it's a southward direction that we have for this. So what happened was back in 2017, when we first initially were informed that we exceeded that and worked with the Department of Defense, we entered into what's called an Environmental Service Cooperative Agreement, an ESCA for short. So the Air Force agreed to pay for the imported water that we would lose from the operation of well 59. Additionally, they paid for the connection of the 2 private wells to municipal source on there. The estimated cost reimbursement up to this year is $7.84 million for that. Additionally, shortly after, we went into an ESCA 2 agreement, and this was to agree to a study, a design, and construction for the well treatment. As I mentioned before, we did a pilot study to determine what was the best remediation action for this PFAS. It was PFOA, PFOS, and we found that GAC was the best action that we utilized. So as of 2 months ago, January, we started January 21st, we became operational on the treatment for well 59. The total cost for that is 3.74. Here's a couple of pictures of the treatment in constructions right now. These are the vessels of the GAC. We have 4 vessels to run 2 in parallel or series 2 and 2 on there. We went finally through a 3rd ESCA. I just found out today that they signed the ESCA 3. This is for the operation and maintenance for the well treatment system, not the well itself, but only the treatment system for that. Includes GAC change out and the disposal. We both agreed that the disposal will be incineration. We talked about the different forms, or there was mention of different forms of disposal. One could go directly to hazardous waste landfill. The Air Force wanted no legacy on there, so they wanted incineration for that. Also included monitoring and reporting costs, and we based that on the DDW permit amendment that we got for that treatment system. This is a 5-year renewable agreement that we have to make sure that we renew. But one thing we did put in there was making sure that if the DoD changed its status of recognizing EPA and recognizing state, that we can reopen the agreement for that. And also, we made sure that the waste liability that's being produced, that GAC that's being disposed, that's their liability, not the water agencies. So this is one of the successful ones, and it's actually one of the first ones in California that actually is specifically for PFAS on for treatment for that. So
Thank you very
That's
much, Al.
what I
That's a very, very illuminating case. And it's great, and really, it really illuminates many of these issues. Thank you for that. I'm going to go ahead and turn to our last question. And again, just a reminder, anyone in the audience, if you have questions, please do use the Q&A. We'll be ready to take those questions in just a few moments. Our last question that we have for our panelists are as follows. Are there any countries, any places generally, that appear to be ahead of the curve with respect to remediation and regulatory reform in this area? If there are such cases, what might we learn from their experiences that are worth applying? And again, Jennifer, if we might start with you.
It's not my real area of expertise, but I am aware again of the cases where Australia, particularly Queensland, which is a state of Queensland, has a policy where you can't use fluorinated AFFF. So they've jumped out ahead of the curve. Norway has again adopted the fluorine free, and other EU countries. So my impression is that the EU countries, again, a little more smaller, more nimble, probably ahead of the curve, both regard to AFFF as well as consumer products. I think Germany, even some years ago, they were talking about apps where you could actually scan like new clothing. You'd have a card on there and it would tell you whether it was PFAS free or not. I do not know if that got implemented, but to hear about government officials operating at that level, that was pretty impressive. And so there's certainly an example and a precedent for that. If I'm I'd like to share a screen and diagram from them. I have permission to do that. I don't quite yet have permission, but I want to put my own source slide up there. Kind of go head to head with others here. Oops, still don't have the ability. I think what I want to do is show people an example of a site. So Shannon, will I be able to share a slide?
Sorry, yes, you are the co-host. You should be a co-host now. Sorry about that.
Okay, thank you. And it's just a quick one. So this probably looks somewhat similar to the map you just saw, though some of the fun stuff of that previous map was a little off screen. But this is a former military base. You see the rank just as you saw in that previous slide. And if I asked you to guess, where's the fire training area? Could you guess?
Right near your arrow.
There's a possibility, and the winner, if you chose this area, you're right. And so this actually is the fire training area. Your next question is, what is all these other things? So I think what we're seeing, especially with like Hunter Anderson Air Force, is in his own and the Air Force's own studies, they're finding we often don't have the luxury of only one release site on a military base, and I'm sure that's your experience as well. I think one curiosity is, what's this little guy over here? That's a crash one time. That's a one-time crash. And if I recall correctly, and it's been a while, this was the first site we ever worked at, by the way. So I think that crash is from 1988. And you can actually see, so it's a timestamp of a single use, and you see a little bit of a plume. And this is a shallow, unconfined aquifer system. I think you have a combination of storage, transfer, hangars, fire training, crash, and landfills around this area. And you can see a heavily impacted water body, and you can see a municipality here. And most of those people worked on a base. My guess is this is probably a fairly common situation where the people who lived and worked on the base, basically ended up contaminating their own water supplies. So I think this isn't necessarily unusual or uncommon. And so you can get a sense for the challenges. If you find hits in downgrading wells, you may address that, but who knows what else is going on there. And that's what people are doing now, is trying to get their heads wrapped around the magnitude of that problem. Ironically, 1988 is the same vintage as an upholstered chair that was rolling down our hallway. And I saw it headed out the door, and I said, Ricky, what do you do to that chair? And he's like, I'm just gonna, give it to surplus. I said, can I have it? And we flipped it upside down, and there's a 1988 manufacturer stamp on it. And we now use it as our textile reference in our lab. We make everybody who's going to do PFAS analysis on papers and textiles do a piece of Ricky's chair. And there are still volatile telomere alcohols on this fabric 30 years after it was made and put in our building. And so this goes back to some original points made. Is we do have sources, even in this room. I mean, I'm sure of it, right? With the kind of performance and functionality you heard about today. So whether it's the environment or you get into these textiles, they're very long-lived, and that's PFAS and PFOA still seen on that. What's fascinating is you can still see volatiles. They're semi-volatiles, and they're still present today. So it's, but I will say we don't know very much about the volatiles in all the systems you've heard today. This may impact things for sure. Landfills are an emission. We know wastewater treatment plants are a volatile emission. We just don't have a lot of information on other volatiles, whether it's a vapor intrusion problem, I don't know. But as you heard earlier, air stripping is not an answer. There's certainly an anecdote out of Minnesota, where they were treating contaminated water with air stripping, and that treated water went onto a playing field, children's school playing field, and they irrigated with the clean water. And that whole soil profile now is full of PFASs. And so I think those are lessons that have been learned actually some time ago, and we won't repeat it. But we really have to have the technology suited for the target. And some of our new targets might actually be volatiles.
Excellent. Thank you. And thank you for that case. Michael?
I think if we think about countries and what's been going around, besides the US, I mean, like Jennifer said, Australia is definitely was ahead in some senses when it had to do with site investigation and establishing national regulations for various PFAS for wastewater. They were probably 2 to 3 years ahead of the US because of their national environment management plan. They've looked at other areas like landfills, but in terms of drinking water, I think the US has actually been more vigilant and a little bit ahead of Australia on that front. If you look at the landscape across the country, many states, California included, have been very vigilant about, establishing, health guidelines and levels. Like the state of California has been very transparent about that and tried to inform the industry and the public on the system and the processes that they're going through to try to get to, an endpoint. I think on the federal level, the pace has been hasn't been as quick as the state. And that might be something that changes with the current administration. Like I said, I think it's very positive that the US has been very proactive. I think one of the unintended consequences, though, of the states having their own levels is that range of levels, I think, does kind of make it a little bit confusing. Like, why is it this level in California, but if I go over to another state, the levels are different? Like, what does that mean? Does that mean that what's safe to drink is different when I go to a different state? I'm being a little facetious there, but I think that's something that when we look at Australia taking sort of a national approach, and even when you look at the EU, they're looking at establishing EU-wide drinking water regulations probably in the next year. So it's sort of a uniform approach. And so it doesn't raise these questions about like, well, why is it different here than there? And so I think if there's something we can learn, and maybe it's more of just a comment, right? We're not going to go back and change what's happened in the last couple of years in terms of all the good activity that's been done by the states. But, having a uniform, approach has its benefits. And maybe that's something that ends up getting pulled together down the line. But I don't have a crystal ball to see if that's going to happen in the next 4 years.
Excellent point. Eugene.
I want to add, I'm going to say Australia for cleanup. Seems like we have lots of votes for Australia. I think for the cleanup techniques, they seem to be a little bit more ahead of the rest of the world. But I would just want to say that I think this is the first time ever that we have a drinking water contaminant problem that's global, that all the different areas of the world's working on it together. Because usually we're really used to localize, or is a US problem, a California problem. This is the first time really it's a global everywhere, that this chemical is used everywhere. And there's academics from around the world trying to tackle this. So it's looking at that front is kind of promising that we have a lot of different techniques. The endpoints where we want, like what Michael said, what's safe drinking water, that level is still to be debated. But at least for the gross cleanup, for the sources, how to clean up all of that, I think there's a lot of technology being used, kind of like what Jennifer says, like in the milligrams per level, or even in the parts per million level. What's the same parts per million, milligrams per. At that level, I think all the site cleanup techniques, those are being worked on. I think, and for the really fine, everybody's still looking at the parts per trillion level, for nanograms per level, for the drinking water level. I think so at least for the treatment techniques wise, I think it's exciting that there are so many countries participating in trying to solve the problem.
And finally, Al?
Yeah, I'm not too familiar with the ones that are out of the country, but I do want to point out most of the work, I mean, recent ones that are being done are centered, and the regulations are right now centered on PFOA and PFOS. These are long chains. Now, manufacturers in the United States, they've actually manufacturers have voluntarily stopped utilizing that type of PFAS. But they've actually used substitutes for theirs. And as Jennifer says, there are thousands of different ones that are out there. And these substitutes are short chains, and the treatments for them are going to be different. Michael mentioned that granular carbon is great for the long chains, but then we, on our pilot study, we do see that the short chains do break through earlier on that. Maybe the ion exchange works better on that, and it's debatable right now. There's always the talk about which one's better on that. But again, with the regulations changing, I know there's the new one for California they're proposing, it's PFBS. There are going to be new requirements that water agencies are going to have to meet, and then new technologies, or technologies that were once acceptable now have to maybe be altered. So there are things that are going to be changing as we get through this, because again, PFAS is a whole host of different constituents, different elements there, the way they were made up and the way they're going to be treated. I mean, you can generalize the treatment, but you're going to have sometimes a specific treatment for certain ones on there. So.
And I think, just to add to Al, and maybe Eugene can weigh in here too, like I think when we look at the shorter chain PFAS and other compounds other than PFOA and PFOS, I think a lot of it is going to come down to the toxicity of those specific compounds and how, what level actually set. And, if you look at PFBS across the country with states that are putting in some sort of a health guidance level, a lot of times, actually in all cases, those levels are higher than the ones that have been set currently for PFOA and PFOS. So we have to take all that into context, because if you have a level at a specific site that's below what the health guidance is, yeah, you might see breakthrough earlier, but if it's below the level that's deemed safe, then it may or may not be an issue for that specific site. And those levels really do vary, depending on the geochemistry of the aquifer that you are pumping from. So that's the thing I would add to what Al said.
Excellent point. We now have some time for questions. We are able to go a little bit beyond 4, so we'll try to get to as many of these questions as possible. Panelists, please, be as brief or as lengthy as you feel is necessary for your answers. One of our participants in the audience asked as follows: I may have missed the known health issues from PFAS and others at the start of the program. What are 4 or 5 main known problems caused by PFAS? Who'd like to begin?
So I guess I would chime in on that. So for the known human health effects for PFAS, I think there are potential indicates that at higher levels of PFAS, it can affect the growth, learning, and behavior of infants and older children. So that's one of the main concerns. Also, it can lower a woman's chance of getting pregnant. So the PFAS itself can interfere with the body's natural hormones. It can increase someone's cholesterol, affects the human immune system, and also increase the risk for cancers. So there are a lot of potential health risks related to PFAS. And the level that we set for response level and notification level it's done by toxicologists under our Office of Environmental Health Assessment, OEHA. They are the ones that sets the level, and then when it's achievable, we adopt it into the Division of Drinking Water as our notification level or response level. So those are the current known health effects related to PFAS.
Excellent. Anyone else care to comment?
I concur with that. And what I've heard, and I would actually, if you're interested in that topic for your panelists, I would highly recommend Jason Condor of Geosyntech. He really gives us fantastic presentations on the human health as well as the ecotox. And what I've learned from him was just exactly what Eugene said. It's actually a whole host of human outcomes. Cancer was not the leading one. It's part of the collection, but it wasn't the main driver, as I understand it, for setting the health advisory levels. But I'd really like to put a plug in for Jason Condor. He makes it very, very approachable, very understandable. And I think he's in your area.
We'll get him. We'll definitely get him. Thank you for that suggestion, Jennifer. Anyone else before we go on to our next question? All right. We have a question also from our audience. Are there emerging studies that show the uptake of PFAS into food sources, proteins, fruits, and vegetables?
Oh, yeah.
And at levels
yeah.
that may require mitigation? What are the actionable levels? Who will have jurisdiction? Jennifer, you want to start us off?
I won't speak to what's acceptable levels. I think other panelists are better positioned, but studies that look at uptake into plants now go back 5 or 6 years. What's really interesting is you see plants pull up the more water soluble fractions. So there's your short chains. They tend to be preferentially accumulate, probably a tug of war, so to speak, between plants and soil. And so the short chains end up, not exclusively, but you'll see a skew toward the short chain in plant matter. I believe people like Lutz Ahrens over in Sweden and others, when they try to understand where humans are getting PFAS, diet is absolutely, if you're not on a contaminated water supply, like in this watershed with like a contaminated water supply, food is thought to be the primary route of exposure. And so it's a really good question. How does it enter our food supply? Out there, questions of food and packaging have been around for a long time, 10, 15 years. Uptake into the plant material itself, fish and meat, definitely, because these are, for those of you who don't know, these materials are considered proteinophiles. So they're associated in us with our proteins and not our fat. So this is one way in which these compounds and classes are very different from our classic ones. So when you think about exposure, we know if in market basket studies, highly proteinaceous foods, especially fish coming from contaminated waters, because the bioconcentration factor for PFAS is pretty big. The map I showed there is a no-eat fish rule there. It's a beautiful river system, but the bass and the trout there exceed the acceptable levels in PFAS. So keep an eye on meats and fish, but also the vegetables.
Excellent. Anyone else want to comment on this? All right. Well, we'll go
I
on.
think,
Add that
Go
that's why there's a big interest in biosolids and where biosolids
right.
go, because biosolids is definitely taking, when you look at the mass flow of PFAS going into wastewater treatment plant, they're of course splitting between your aqueous effluent stream and you've got your biosolid stream. And when you look at our old mass balance work we did with Chris Higgins when he was down at Stanford, is the mass going out of a treatment plant, even on a composited time-weighted average over a week, actually is higher than what goes in. So you got to watch both of those waste streams. And we know that the biosolids here in Oregon, I think you can apply biosolids and then you can have a crop 18 months later. And you know these things aren't going anywhere. So I think there's a real a large number of people looking at biosolids and the connection to the food chain in a lot of states. Michigan and Wisconsin and Minnesota are ones that come easily to mind.
Right. Excellent.
and just to add on that, I mean, a lot of us on this panel, you know, we're focused on the water and wastewater market, and that's what we're most familiar with. But, you know, where it crosses with, you know, food sources, I think is exactly what Jennifer mentioned, right? When we have recycled water and also biosolids that are often, you know, reused to support those industries as a way to conserve water and resources, you know, that's been done for years. And, you know, you have this issue that, you know, has recently popped up, and it's creating a lot of interest in, you know, and what's the right thing to do about it. And I think there's still a lot of work being done right now, like Jennifer's mentioned, around the biosolids. And, you know, if we look at, you know, what California is doing, you know, there's a lot of monitoring going on to try to understand, you know, the presence in the wastewater and the recycled water before even stepping back and thinking about, well, what do we do about it? And so it is a very big and important topic. And, you know, there's been a lot of focus on drinking water in, you know, the last couple of years, because, you know, that's the immediate concern, right? That's what we can address immediately. But, you know, how do we move backwards into, well, where is it coming from and where else do we need to be concerned about it? I think that's really what we're going to be seeing going forward as sort of the next wave.
And I want to add, is the challenge is not just water, as everybody's mentioned. It's kind of on as part of the food that we put in our mouths is the cookware that it could be coming from, and also the food packaging as well. So really, it is a multifaceted challenge. It's not just from the fruits and vegetables you produce in the field. It's also in how you process it, the packaging that we use for preparing or consuming the food. It's also coming from those products. So it is very difficult.
And I heard of an issue just in the last year. I think it's the city of Seattle has a goal of recycling their food waste and using a very, you know, scale up a compost system. And sure enough, the residues in food make it into compost. And they're discovering that their compost has detectable residues. And I don't know what's happened since then. But here you have a city who would like to, you know, just as you heard earlier, conserve energy, conserve resources, and conserve that organic matter and the nutrients. And yet they find it with PFAS. So I don't know what the current update is, whether they've changed a policy, but there's certainly an awareness. And they were trying to implement, you know, a strategy on a city scale, and they ran into that issue. So I don't know. Does anyone on this panel know anything about composting in the state of California or other states and how it's impacted by PFAS?
It's a great question.
And just speaking of the regulations on there, one of the big key things that you're talking about could be in biosolids. One of the requirements now is that biosolids used to sometimes go to the landfill, and it no longer can. Organic waste cannot go there. And so now it needs to be applied either to lands itself or organic waste, not organic waste, but organic supplement for fields, either here in California or like ours is sent out to Yuma, Arizona, where the ag fields are out there on there. One of the things I did want to mention also was that on the state investigated order, which has been issued in 2020, we're currently in the study of looking at the influent effluent, as well as the biosolids. requirement. So we are doing monitoring as part of a year-long study with a lot of wastewater agencies throughout the state. So there will be more information as that gets finished up for that.
It's great. It's a topic worth expanding on through a panel on itself. And we're definitely going to look at doing exactly that. Let me go ahead and see if we can get through some of these other questions. It's a great set of answers, panel. Thank you. Are there any emerging treatments of the quote destroy type becoming available?
Yes, I have a collaborator, Colorado School of Mines, Tim Strathman, has something he calls a hydrothermal alkaline destruction. And it's really just cranking up the pH, cranking up the temperature, you're subcritical, but it really shows promise. And I think I can't speak to the scale at this point or the costs, but it's definitely promising from its ability to destroy the molecule down to fluoride and CO2. So I think that's a technology we want to keep an eye on. Again, that's Tim Strathman, Colorado School of Mines, got started back in 2019, and I think it shows promise.
I think the key to a lot of the emerging technologies, anytime you're trying to destroy, something that has a strong bond like the carbon fluorine bond, the energy required for that is a key consideration. And it's like any process that's under development, right? Like you have to be able to prove it at different scales, right? So you have to be able to demonstrate it on the laboratory and bench scale initially, and then you have to move it onto a larger scale, which I think some of these technologies are being researched in that forum. And then there's a little bit of a jump to, well, how do I take it from a pilot scale to a full scale system that can be operated and maintained by someone at a level that's required. And I think that's really the key for the researchers right now is how do I get something that works to be scalable for someone to implement within the budget that they have.
Yeah, those of course are very good points. And CERDIP, which is the big funding agency that's DOE, DOD, and EPA, so SERDP, they are definitely funding frontline research. And out of that portfolio of research, I think the alkaline process is pretty interesting. And the bar is pretty high because people are becoming very aware that you really need to have multiple lines of evidence. You can't just show disappearance of a compound because these things are a little tricky to measure, and you can have artifacts. So I think closing the mass balance, kind of meeting really rigorous definitions. And you're right, it's going to be kind of a pyramid. Like, do I have proof of concept? Can I close the mass balance? And then you get into scaling and costs. And, ideally you don't want any secondary kinds of waste. So you're right. These technologies, I think people are getting a little wiser about really tightening up the criteria, really requiring evidence, because there were some early technologies that weren't really viable, but without those criteria and that kind of accepted criteria, I think you had a potential for some snake oil. And now the rigors are much higher. So I think the bar is higher and the inspection is higher, and people are much more aware of the need to close the mass balance on the fluorine, and that just having a lot of missing mass is probably not okay. And so I think that's a belief that's being widely shared now among engineers and others with this problem.
Excellent. I think we've got time for at least one more question. And the question simply by one of our audience members is, are there detectable levels of PFAS in water imported via the Metropolitan Water District of Southern California?
I can answer that one. They do testing of that, and we also did testing on that. It's non-detect for that. So for the imported water, yes, it's very clean that we find. Okay. It's non-detect at the levels for that. So.
And as long as we're at it, Al, we have a question specifically that is directed to you. Was ion exchange considered for the treatment system near March Air Force Base?
Yes, it was. We looked at different units, RO, ion exchange, and GAC. And based on the cost and the treatment viability, as well as the ability to remove with GAC, that's why that was chosen on that. Ion's going to be a little bit more expensive to do it. But if we have to do short change, it might have been better if we were targeting that. So.
Excellent. We have one more question, and I'll share it with all of you, and it actually sort of ties back to the food question as well. Would older generations that used Teflon pans and had longer exposures be more likely to be shedding these contaminants at a significantly higher level? Who'd like to start us off?
I'll jump in there. Oh, go ahead, Al.
Oh, I forgot where the study was, where they actually looked at the serum of blood on there. And back in 2000, they had the high peak when and this was specifically PFOA, PFOS. To find a blank study, they actually had historical blood that was before the war, like the Korean War, before in the 1950s. And so they had to use that to actually test that to find where there was not. So when we looked at the blood serum, and I forgot where the study was, and maybe Jennifer, you know about the study I'm talking about. They saw increases over time, and now they're seeing a decrease of that because the removal of PFOA, PFOS in there. So that I need to look up what the study is. I'm just going off the top of the head, but I remember seeing the graph and the discussion about that. So
the Teflon pan data is actually pretty, I haven't seen any new studies on the Teflon pan for, I think this goes back maybe 10 or 15 years now. I think I'd be interested to redo the study with some newer methods. We now have total fluorine measurements. We now have volatile measures. We have PFAS, individual molecules. We have a broader array. I think it would be interesting to go back. I just don't know of any real current studies where people, partly because there isn't any funding for it, as far as I can tell. There are definitely some other areas. What I think is universally understood is you don't want to overheat those pans. There's a lot of attention now on sub-incineration temperatures. And we know that highly fluorinated substances do evolve gas phase and perhaps particulate phase at sub-incinerating temperatures. It's actually a really big area of study. So I actually had quite some time ago a Teflon pan overheat in my house with my daughter inside. And we scooted that pan outside and opened up the house and left it. Just simply because we'd heard, you don't know. And it just, anything overheats, right? You want to air out a room. But I'm sure others have had that experience. But there really is, I would say, a lack of modern data on that question with modern pans.
Excellent. Any further thoughts by any of the panelists?
It's an evolving field right now. We're just new regulations coming out. So
we're going to continue tracking it. I cannot thank you enough, panelists, Jennifer Field, Alfred Javier, Michael Wong, Eugene Long. This has been really tremendous. Again, to our audience, this has been recorded, and it's great because there's a lot of information in here that you're going to want to go back and look at, consider, contact people. This will not be the last colloquium we will have on the issue of PFAS, PFOS, I can assure you. I want to thank all of you for attending today. Want to thank also Shannon Roback, the Associate Director for Water UCI, for organizing the panel, Doug Colby and Ann Parker with the School of Social Ecology for all of their work facilitating this. This has just been tremendous. Thank you very much. And maybe at some point we'll do an update involving you folks if you're available. We'd love to have you back. Thank you.
Thank you.
Thank you.
Bye-bye.